Hi everyone, welcome back to my channel. In this video, we will solve the following inequality 1 by 1 square plus 1 by 2 square plus up to 1 by n square is less or equal to 2 minus 1 by n. And we will prove this by using mathematical induction. So first, we will denote this statement by Pn. So let Pn denote the above statement. So first let us check for n equal to 1. So for n equal to 1, our LHS term will be 1 by 1 square, which is 1, and RHS is equal to 2 minus 1 by 1, which is 2 minus 1, which is 1. So we get LHS is less equal to RHS, so that will imply that P of 1 is true. Now let P of n is true, then we will try to prove P of n plus 1 is also true. So to show P of n plus 1 is true by assuming Pn is true. So Pn is true, that will imply that 1 by 1 square plus 1 by 2 square up to 1 by n square is this equal to 2 minus 1 by n. Okay, now what we need to show? So Pn plus 1 is true. That means 1 by 1 square plus 1 by 2 square plus 1 by n plus 1 whole square is less equal to 2 minus 1 by n plus 1. Okay, so we need to show this statement. So first, so consider that left hand side is 1 by 1 square plus 1 by 2 square up to 1 by n plus 1 whole square. Okay, so this left hand side we can write it as 1 by 1 square plus 1 by 2 square up to 1 by n square plus 1 by n plus 1 whole square. Now by mathematical induction, we know that this term is already less or equal to 2 minus 1 by n, because we assume Pn is true, and then plus 1 by n plus 1 whole square as it is. Now note that n plus 1 whole square is bigger or equal to n times n plus 1 for every n, because here we have 2n plus 1 and here we have n into n plus 1. So obviously n plus 1 whole square is bigger than n into n plus 1. So 1 by n plus 1 whole square will be less n times n plus 1. So we can write 2 minus 1 by n, and this 1 by n plus 1 whole square is less than n times n plus 1. Now if we calculate this, we have 2 minus 1 by n minus n into n plus 1. So then 2 minus n into n plus 1, and here we have n plus 1 minus 1. So we have 2 minus n by n into n plus 1. So that is equal to 2 minus 1 by n plus 1. So we get Pn plus 1 is true. So we have Pn plus 1 is true. So what we got so far? So we get P1 is true. And if we assume Pn is true, then that will imply P of n plus 1 is true. So by the mathematical induction, we can say that Pn is true for every n belongs to n. Hence, we get the inequality 1 by 1 square plus 1 by 2 square plus up to 1 by n square is less equal to 2 minus 1 by n.